Hello everybody and welcome to today's webinar. So good morning, good evening or good afternoon depending on where you are in the world. So today's webinar is a technical webinar. It's called Bluetooth Low Energy Communication with MediaTek LinkIt ONE. It's going to be presented by Philip Handschin, who a few of you know, who is a technical consultant here at MediaTek Labs. I'm now going to hand over to Philip, who will take us through Bluetooth Low Energy Communication.
Thank you, Michael, and a warm welcome to everyone. As you said, today I will talk about Bluetooth Low Energy, and I'll give you a short introduction of the structure of today's webinar. So first, I will give a very short introduction on MediaTek Labs. Then I will talk to you like what you have to do with the SDK in order to use Bluetooth communication. And then I will talk about GATT, which is the protocol that is used for Bluetooth low energy communication. Then we will have a hello world example, so the very basic. And then we have a more sophisticated example where we read out a temperature and we then notify the smartphone or the client that like a new temperature is read out, and we transmit this temperature. And in the end, as Michael already mentioned, there will be time for questions. So let's get started with MediaTek Labs. Some of you might know that already. So we are like a completely free developer program. And we have lots of resources on our website. We host regular webinars, as you know, technical, but also business webinars where we can help you in various different things. Like our ethos is that we help you to go from an idea to a prototype to a product with various different things. So with our hardware kits, with our software development kits, we have a very active forum where our technical consultants all over the world are answering your questions very quickly. And we have also a cloud solution, so there's plenty of tools to help you get your idea into reality. This is our portfolio currently. We will continue to add developer boards. You most definitely know the LinkIt ONE and the LinkIt Assist probably as well. We also have then the LinkIt Connect 7681, which is a Wi-Fi system on chip. But our latest addition is a very exciting product, the LinkIt Smart 7688. It's an open source Wi-Fi platform, so it runs on Linux, and you can program it with Python, node.js, Arduino, or do system programming in C itself. So check that out. It's definitely worth a look. And here it's kind of like people like you. We have a huge community making a lot of different projects. So it's worth going to Hackster.io or Instructables to see all these amazing creations with our boards. Right. So enough about MediaTek Labs. Let's talk about the LinkIt ONE and what we have to do to get Bluetooth up and running. From a hardware perspective, it's actually very little. So if we look at the back of the board, on the left-hand side, we have 3 connectors for antennas, the GPS antenna, the Wi-Fi Bluetooth antenna, and the GSM antenna. So I highly recommend that you always connect the Wi-Fi and Bluetooth antenna, like the middle one here in the picture, before you start your project with Bluetooth. It just makes sure that you definitely have a good connection going forward. Right, that's everything from a hardware perspective, because the LinkIt ONE has everything on the board already to start programming. So once you've connected your antenna, you then can concentrate on the software. But before we talk about the software, let's talk a bit about GATT. So GATT means generic attribute profile. It basically handles the data transfer between 2 Bluetooth low energy devices. It's based on attributes. So in very basic terms is you read and write attributes from a device. And there are 4 different ways of transferring data, which I will describe later on. And again, this is low energy and also low data rate. So the maximum bytes you can transfer per transaction is 22 bytes. So if you look at a higher data rate, if you want to transfer more data, then I recommend to go with standard Bluetooth, which is also supported with the LinkIt ONE, which can support much higher data throughput, and this is then achieved by a serial connection through normal Bluetooth. But now we're looking at Bluetooth Low Energy. So let's have a closer look at GATT. So how does the network look like? So we have two types of devices. One is the central device, which is normally a phone or a tablet or computer, and then we have peripheral devices, which is normally your Bluetooth Low Energy sensor, like maybe your heart rate monitor or anything similar. And the peripheral device can only have one connection at a time. So a peripheral device can only be connected to one central device at a time. And once it is connected, it won't be discoverable. So you won't be able to see it if you scan for Bluetooth Low Energy devices. The central device, on the other hand, can have multiple connections at a time. So it can be connected to multiple Bluetooth devices. In our example, we will have an Android phone as our central device, and we will have the LinkIt ONE as our peripheral device. But this could also be the other way around. So any device can be a peripheral or a central device. It's just kind of how you define it. Then we have different roles in the GATT architecture. So we have servers and we have clients. And servers are the ones who deliver data to the client. So, or also send notification that new data is available. And the client is the device that normally receives the data. And again, both peripheral and central devices can be both. But to make it more real, we have a real-world example. So in this case, we have a activity tracker, a Bluetooth Low Energy activity tracker, which is the server, because this wristband serves basically the client, the smartphone, with data. So with your heart rate and with the step tracker, etc. So this is a typical example of server and client. Then we talk about like the data structure. As I said, like very basic terms, it's kind of like it's an exchange of attributes, but attributes are grouped into characteristics. So you build characteristics. Characteristics can be a heartbeat, and you can also specify the permission for that characteristic. So you have the heartbeat, which is read-only, and then you can have, additionally to the heartbeat, is a timestamp. So you know when this heartbeat was read. And you can have, for example, a read-write on that timestamp. You can bundle multiple characteristics together to one service. And then you can also have multiple services running on as on your device. So it's just kind of like how the data is structured. And this data is then running on the server, and it can be then read from the client, or it can then also push these characteristics, or when a characteristic, the value changed, it can push it then to the client. We need unique identifiers for these characteristics and services. So the standard says like you can have completely random unique identifiers which you make up. They have to be 128-bit long. And yeah, you can randomly generate these unique identifiers. But each service and each characteristic has to have a unique identifier. You can also use the standardized unique identifiers. They are 16-bit longs, and they are standardized by the Bluetooth Special Interest Group. They define these services and characteristics to make devices compatible with each other. So if you want to create a heart rate monitor, there are plenty of other heart rate monitors out there and devices that can read heart rate monitors. And so they standardized these unique identifiers so that they become compatible with each other. So if you plan to do a commercial device, I would highly recommend you to check out these standardized services and characteristics and see if your device fits into that, and then use the official suggested unique identifiers. So here we have a set of standard IDs. So you see for service, we have like a battery service, which you have the unique identifier at the end there. But there can also be like a running speed and cadence service. And in characteristics, we have like a glucose measurement or a heart rate measurement. So if you do anything like that, then please go to the developer.bluetooth.org website and go to GATT specifications to see if that fits with your project. Other than that, just create a random UUID. So how do we transfer then data? We have, as I said before, we have like 4 different types. First one is read. This is requested by the client, and the server then will respond with the value. So for example, the client says, give me the heart rate at the time. The server will then transfer these characteristics to the client. Write again is requested by the client, and then the server stores this new value on the device, depending if you obviously have the correct permissions to do that. Notify is indicated by the server. So the server lets the client know that I want to be informed when this characteristic changes, and please give me the latest update. So you can say like, please inform me every time the heart rate changes. And so then the server will, every time the heart rate changes, it will send a notification to the client, and then the client can read it out. And indicate is exactly the same than notify, but it is acknowledged. So notify is unacknowledged, so messages can potentially be lost, but indicate is acknowledged, so it's a bit of overhead in terms of data transfer, but you know that it definitely arrives. So when should you use which one? So if the client needs to send data to a server, then you use write, straightforward. If the client needs to get data from the server on demand, so you just want to read out right now, then you use read, right? You send a read request. But the interesting one is if the server needs to send data to the client without the client requesting it first. So you just want that whenever there's new data, the server will notify the client about new data. You use notify or indicate. This is very handy because then the client doesn't always have to ask, is there an update? Please give me an update. So it will just kind of automatically notify. But please be aware that for notify to work, the client has to first subscribe to these notifications. Otherwise, the notification won't arrive. So I hope this gave you a little bit of an overview of GATT. I know it can be quite daunting, but I hope this gave you a good introduction into it. And let's now see a practical real-world example. So we have the Hello World example. We will create a server on the LinkIt ONE, and for that we have to specify a service. As I said before, like the characteristics are grouped into a service. So we have to create at least one service and one characteristics. So we'll do that. And then we have to handle the read request from the client. And what we want to do is we just want to give a string back. So when we read on that characteristic, we just want to give a string back saying, hello GATT world. Just to give you an overview, as I said, the server will be the LinkIt ONE, and the client will be an Android phone. And the client then in the end will send a read request to the LinkIt ONE, and the LinkIt ONE will respond with hello GATT world. On the Android device, I will use the app called BLE Scanner. This is a very handy app to discover all BLE devices around you. You then can connect to these devices, and it will show you kind of what services are available, and you can also write and read these different characteristics. So I highly recommend this app for development. So how are we going to do the Hello World example? We first have to extend the LGAT service class. So we will implement our own one. In that class, or like in that extension, we will have to implement the onRead function. And once we kind of finished creating this service, we then have to initialize an LGAT server with our implementation. And we have to handle the incoming requests. So let's have a look how we're going to do that. So first, as I said, we have to implement our own service. So here we extend the LGAT service, and we will create our own service. We call it Hello World Service. For that, we have to implement all these functions. At the moment, afterwards, we're only interested in the onRead function. But we still need to implement all other ones as well, just to be able to handle all requests. So this is pretty standard. Now we can go to the implementation. So we call that Hello World Service H. And then we implement it in the Hello World Service CPP file. The whole thing is developed in Arduino, where you have other resources on our website, how to get Arduino up and running, and our SDK with it for the LinkIt ONE. So, right, let's go back to the Hello World service. So here is the interesting bit, the LGAT service info. So here's the information about our service. And we define here the service. So we have to define the unique identifier. And if it's a primary service or a secondary one, and this is a primary one. And for service, we don't need any other characteristics. And so within that service, we have one characteristic we define here. And this characteristic, again, have a random unique ID, 128-bit long. And this is not a primary characteristics. And here I define my the property. So we can read that characteristic, and we also give the permission to read that characteristic. So this will be read out once the server is started, and then it will be the service will be established with the characteristic we defined in here. The next thing, which is crucial for our Hello World demo, is the onRead function. So let me scroll down to the onRead. So here we go. We have onRead implemented here. And what we do, if we are connected, we create a new attribute value, and we create a string, and we copy that string into that attribute value, and we then print it out to the system console just to see, for debug information. But then we basically send that value back. We do that by data.acknowledge OK. So to send that the data back to the server. So this is the only function that we are interested in at the moment, because we will only implement the onRead functionality. So here we are on our inno file in Arduino, where we have a setup function and the loop function. So in the setup function, we will have starting the serial port, but more importantly, we start the LGAT server. So this is a class that is included in our SDK, and you need to call that to begin to start the server. And here we pass along like how many different services we will run. So we will run only one, and we will run the Hello World service. So where did we have the Hello World from? We defined it up here. So we implemented, we included the Hello World service we just implemented, and we create an instance of this Hello World service as Hello World. So here we start the server with this service. And that's all we have to do. So from then on, basically the board starts broadcasting this service with like the properties and permission we defined in our service. And the only thing we have to do in our loop is kind of to wait for a bit, so we don't do it all the time, and then we handle events. So handle events is kind of like we deal with any sort of request that is coming along, like it can be a write request, read request, whatever we allow or permit. So as I said, like this is a very, very basic example, but it gives you a good indication of how to get started. So now I will I connect the LinkIt ONE board to my computer with like a micro USB cable. I will see it then in my ports here. COM12, yeah, that's fine. I have the LinkIt ONE selected, and I can then upload it to the board. So this will take a minute. In the meantime, I'll okay, it's uploading. In the meantime, I started up the Bluetooth scanner app, which then we will be able to see the Bluetooth low energy device. So uploading is done. So let's have a look at, so this is my Android phone. I use this clever tool to kind of display whatever is going on my phone. So here we see the GATT example is up and running, and we can now try to connect to this Bluetooth low energy device. So we press connect. Oh. Again, we press connect. Yeah, there we go. So now it's discovering services. So it will broadcast the service we just defined. So it should have like one custom service. Yep. It already is displaying on my phone, unfortunately not on the screen. Ah, there we go. So here we go. We have our defined custom service. So if you look here on our definition, if you see, like, this is exactly the unique identifier you will see here, and also the characteristic. And this tool is very, very nice to use because you then also see immediately what kind of properties and permissions you have on that characteristic. So you have properties as read, and you also have the rights to read it. And so now we can send a read request on that characteristic by pressing this little R. And this can take now a few seconds because we only handle every 5 seconds we handle the events. So let me press R, and then within a few seconds we will see that we should get the hello GATT world back. Yeah, the screen is a bit slow. I have it already here on my phone, so it should come here any minute now. There we go. So the value hello GATT world came back, and you also have the hex value. So this is a very, very minimum example, a simple example of how to define your GATT service with the properties and permissions. and just responds to a read request. But let's have a look at something more complex because, because for me, the read request is probably not the most used one. I would think the indicate one is probably much more a real world scenario. So with this temperature example, again, we will implement a LGAT service. We will initialize the LGAT server with our implementation. And then in the loop in Arduino, we will read out the temperature from a temperature sensor. And we will then, if the temperature has changed since the last readout, we will send then an indication to the client that the temperature has changed and there's a new value available, which I think is much closer to a real world scenario than just kind of answering to read services, read requests. So if we now go to our temperature service, again, it's like extends the LGAT service, and we have like the default, the implementation of all the functions, and then we define our specific temperature service. So here again, we have like a unique identifier randomly generated, and we have one characteristic. And here we have now two properties. We have the property to notify and the read property, and the permission to read the characteristic. So slight difference to before, we added the notify property here. And then we don't have to implement the indication because we do that in the file, in our normal Arduino file. What you can see here is the DHT-H and the DHT-CTP. They are basically the drivers for the temperature and humidity sensor. There are other video tutorials where I describe how to use this temperature and humidity sensor, so please check our YouTube channel. There are plenty of examples. So we'll mainly focus now on the Bluetooth part and not on the temperature sensor. So again, we have to include like our temperature service, the LGAT UUID, and we also include now our temperature and humidity sensor driver and the server, the Bluetooth server. Here we include some file, or we define some files for like our temperature and humidity sensor. Again, that's described in a different tutorial. But we have a global variable for the temperature, and then we initialize our temperature service, so we have it ready. And in our setup function here, again, we can start our server. Like we will start one service, and it's the temperature service, and that's it in the setup function. And so the loop will be slightly more complicated. So again, we just do it every 5 seconds. We will handle the events. So whatever happens, we will handle them. So the GATT server does that, which is great. But then we also check if the temperature service is connected. And once you have a connection, so like a client is connected to that service, we start reading out the temperature and humidity. We do that here. So the DHT is our variable for accessing the temperature and humidity sensor. We read out the temperature and humidity, and we check if the temperature has changed since last time. If it hasn't, then we won't do a thing. But if it has, we will obviously set the new temperature to the global variable. We create a new LGAT attribute value. And in this case, we create a string which says temperature and then the temperature that we read out. We print it to the console for debugging purposes. We then turn that string into a constant char array. We have then, and then we copy this into the value, the LGAT attribute value, and then we take the temperature service and we send an indication to our client that this value has changed, and this then makes the client query the new value, and that's it. That's how you create a characteristic which then indicates to the client that the value has changed. So again, let's upload that to our LinkIt ONE board. The temperature and humidity sensor is connected to one of the growth connectors on the board, and yeah, it will read out the temperature every 5 seconds. So let's have a look. Once this is uploaded, we should see the custom service and characteristic change on the app, and then we should be able to see updates from the temperature sensor. So it's done uploading, so it's probably rebooting. So let's have a look. Oh, yeah. Let's unlock the phone. Great stuff. So we see we have the GATT example again, our Bluetooth LE device. We connect to it. We're discovering services. And now we should have a slightly different view. So we have a custom characteristic again, but now we have read and notify. But we don't see any temperature string coming in. But I'm surely it passed 5 or 10 seconds already. So why is it not coming in? And as you remember, with indications, the client has to subscribe to these notifications, and so we have to first send a notification to the server in order to receive them. So if I click notify now here on the Android device, I will then see updates coming in once the server handles this notification. This can take now a few seconds because we only read it out every 5 seconds, and also it has to be like that the temperature has changed since the last time. So I might want to take the sensor into my hands, so that the temperature changes actually. There we go. We have an update. So now we have the temperature 23.9. So I'll keep the sensor in my hand. So we should see yeah, there we go, temperature 24.9. So now every 5 seconds, it will try to read out the temperature. And if the temperature changed, we will send an indication. There we go again. So I'll let the sensor go. So hopefully it will, it still goes up. Yeah, so I think this is a real world application where you send indications when something has changed. Otherwise, there's no need of any communication between the server and the client. So you can also save battery life. Right. Oh. Let's go back to our presentation. Just a quick tip. I think the best is, or in order to get started, is to use our example code. You will find it under Arduino file examples LGAT. just a quick reminder, everything in the example code that starts with a L is created by MediaTek. So you have like different LBT, LDAT times. So just, go ahead and test all these different example codes. Then you go to, on the LGATT, you go to UART over GATT, and then you go to LGATT-S, which stands for GATT server. So I'll just show you that. So you go to File, Examples, and then you go to LGATT, and then you have UART over GATT, and then you have the GATT server. And then again, you will see like actually two implementations of services, and then you can just take it from there. It's probably the easiest way to get an example up and running. Right, so now I would open the floor for questions. I hope this gave you a good introduction. So, Michael, do we have any questions?
Oh, hi, Philip. Yes, thank you very much, Phil, for that very interesting demonstration there. Yes, we do have a question, but before we answer that one, if anyone else has questions, please do type them into your console now, and we will be delighted to answer them. So our first question is from Oleg, who's asking, is it possible to use Python for GATT?
Thank you very much for this question. The LinkIt ONE software development kit is available for Arduino only. So unfortunately, you can't program it with Python. Only our LinkIt Smart 7688 board is available for programming with Python, but this board is Wi-Fi only, I'm afraid. So, but I highly recommend to give Arduino a go. I found it very easy and to program. So even with your with a Python background, I think you quickly get your head around the Arduino development environment.
Thank you, Philip. Thank you, Philip. We have another question from Jiva, who's asking, how does UART serial comms work?
I have to say, like, could you be more specific about this question?
Jiva, would it be possible to provide more details around your questions? At the moment, we've just got how does the UART serial comms work? So if you could maybe narrow that down a bit, that'd be helpful. Sorry, yes, thank you, Jiva. So we've got does Arduino support the UART serial?
Yes. As far as I understand your question, you can access the UART serial with serial 1. So you know when we program in our example, we used here the serial print line, which is like our COM port. But if you use serial 1, this is actually the UART port, which you can then access it like that. I hope this answers your question.
Thank you, Phil. So we have another question from Ismail, who's saying that they've checked the API library for LinkIt ONE but couldn't find the source file. Only have the header file. So I don't know, Phil, if that's one for the technical forums or not.
Yes, like certain aspects, because the LinkIt ONE, the operating system is based on Nucleus, which is a licensed operating system. So certain parts are not publicly available because we had to pay the license fee. So it could very well be that you can see the header file, but like the source files are not open source, I'm afraid. But check the forum. Maybe yeah, that's a good point, Michael.
Yeah. So Ismail, if you post on the MediaTek Labs technical forums. That's labs.mediatek.com, and then if you go to the forum and post there, our technical consultant team will be able to help you out with that one. And then we've got another question. If we can suggest how to organise the UUIDs for devices and services to be able to manage access to devices from different users.
Yes. Well, you can. First of all, if you use the 128-bit ones, you can randomly generate these UUIDs, or you can come up with your own ones. So however one they fit best in the organization or to your device. But I think access to devices from different users. If you mean like maybe other like third-party devices, then I strongly recommend to go with the predefined UUIDs from the Bluetooth Special Interest Group. It's worth having a look on their website. I think it's Bluetooth.org. They have a whole list of specifications for characteristics and also units and services and whole profiles. So like they have like a whole structure of UIDs for like a heart rate monitor, for example. So if I think that's a good place to start.
Thank you, Phil. So we have another question from Ismail Sahins wanting the MT2502 reference manual datasheet. Again, I think if you post that request on the MediaTek Labs technical forums, then we can take it from there.
Yeah, I mean there are a lot of the documentation is available on the lab's website. Anything more specific to the 2502, just specifically for the chip, it's probably it will be worth registering on our Labs Partner Connect site, so you can register your business, and then you can get in touch with our business development team. Because if you have specific questions about the chip and how to use it in your end product, then it's probably worth registering your company and going through business development.